Welcome once again to COMxL tutorials. In this section, we will talk about how the COMxL can be used to solve linear programming problems with a simpler solver. So we have our linear programming problem over here with our objective function 3x1 plus 7x2 and our constraints as this inequalities. So to feed in the problem into the simpler solver, we extract the equivalent of the constraints and we set our function below our constraint. So if I come in the Excel worksheet, so we have our first constraint to be 5x1 plus 3x2. But then since it is maximized, you must make sure that all the constraints are less than or equal to. Since it is maximized, they must be less than or equal to. If it was to be minimized, these constraints should be greater than or equal to. So to feed it in the simplest solver, we extract our constraints. So for the first constraint is 5x1 plus 3x2 less or equal to 50. So we have 5 as coefficients, 3 and 50. And for the next constraint is 2, 3, 29, 1, 4, 32. And we set our objective function below our system of constraints. So 3, 7, and 0. So this is the problem matrix of the of the linear programming problem. So we start our simplest solver. It says select the range of problem matrix. So the cell that contains our problem matrix. So we click on this and it's allowed to select. And this problem is maximization. So we leave it to be like that. So we can choose to do the minimization problem or the maximization problem. But in this case, we focus on maximization. Yes. And output location. So you need to choose a part on the worksheets that it will send the output to. So let's select this region. So if I click on solve, it will run the simplest solver and to give me my function values for the variable x1 and variable x2 and the actual objective function if you feed the values of the x1 and x2 into the objective function. So for the first tableau, it extracts this problem and add the slack variables over here. So we have 3 slack variables since there are 3 constraints to the problem. So x1, x2, x3, and this z is for the objective function variable, that is it. And we have the far right as the constant of the objective function of the linear programming problem, 52 is 32 is 0. So the next tableau is that it will look at the bottom of the first tableau. The more the value that is highly negative, it will pick that column and it will work with that column. So if you look at this tableau, we have minus 3 and minus 7, with minus 7 being more negative than minus 3. So the next column to work with is going to be the x2 column. So it selects the x2 column and converts it to column of 1s and 0s. Now in the first tableau, we have x1 and x2 and x3, and on the far left we have x1 and x2 and x3. These variables over here are the active variables. Why active variables? In the column of x1 and x2, x3, there are only 2 digits over there, 1 and 0, with a single 1 and several zeros. This means that the column and the variable x1 is an active variable because it can easily be determined. So if it is indeed active variable, then we can from here infer that x1 value is 50 and x2 value is 29 and x3 is 32 and the function itself to be optimized is 0. But then that is not the case, since if we look at the objective function, an increase in 1 unit of x1 will cause an increase in 3 units of the objective function. So that means if we can increase the x1 to a more positive value, the z value also increase. And if we can increase the x2 to a more positive value, the z value will increase. So we work on them and we increase the x1 and x2 value to a more positive value. So that is why we pick the the lower bottom of the x2 column since it is more negative. So we set this to an active variable by converting it. We have x2 as the next active variable. And we do same for the x1 column since it is also the more negative in the next tableau. And we have this. So after the third tableau, we have the values of x1 to be 4, x2 of 7, s1 itself is 9, x2, s3 of 0, and our updating function value to be 61. Once again, if the simplest solver is used to solve problems, that is maximization, the constraint must be less or equal to. But if the set problems is for minimization, this must be greater than or equal to. Thank you very much.